This is the very first session. Therefore, we'll have a kind of a soft start. And today, of course, as you know, we are going to start this mobile communication subject. And this subject, of course, is a very interesting subject. Of course, a subject that has a demand as well by considering the current, the context, especially from say data demand point of view and application point of view as well. Therefore, we'll slowly get into the subject. And there, today, what I am trying to do is I am trying to give a briefing on the content of this entire program. And other than that, I am focusing to step into the syllabus little by little by introducing signals, signal behavior, because normally we talk about signal, telecommunication signal, maybe sometimes we say antennas are transmitting signals, likewise, but still probably we don't know what these signals are. Sometimes you may not know, but we need to understand it better, in a better way, from a better or from a different angle. And at the same time, I may go through the mobile communication roadmap as well, not in detail, but in a brief level. Because this mobile communication mainly supposed to go through all these mobile technology generations. As you all know, we have first generation, second generation, third generation, fourth and fifth. Today, most of the people are talking about fifth generation, 5G. However, it's coming from the first generation, and therefore, while we are completing this entire syllabus, intended syllabus, you may get a very good or thorough understanding on all these mobile technology generations. Not only that, even including respective theories, applications, and things like as well relevant to the inline to the syllabus. That is the focus of today's session. Signals can be mainly divided into two main categories. One is called primary signal. The other one is called secondary signal. Primary and secondary signal. Of course, you can categorize signal in different ways. Maybe sometimes you may say signals can be categorized into analog signal, digital signals. Maybe you can say a low frequency signal, medium frequency signal, high frequency signal, likewise AC signal, DC signal. Likewise, there can be different signal categorizations. But from our syllabus point of view, this categorization is very much important. What's that? Primary signal and secondary signal. Why we say a primary signal? If a signal has only one frequency component, if a signal has only one frequency component or one frequency, we call that signal as a primary signal. For example, a cos signal is a primary signal, a sine signal is a primary signal. Then sometimes you may wonder what this cos and what this sine is. You can see it in the next slide, but for the time being, probably you know what cosine means. And maybe in my future slides, you may see what cos, what sine means. I mean, from signal shape point of view. Therefore, in brief, primary means a signal that has only one frequency components. Sometimes we call this signal as a fundamental signals. Fundamental. Primary means fundamental. Fundamental signals. And the other category is secondary signal, or in other words, non-fundamental signals. Why we say secondary or non-fundamental? Because all these secondary signals can be generated by combining two or more primary signals. Therefore, to construct, to build secondary signals, you need primary signals. You need primary signals. Therefore, primary signal is the source of the secondary signal. Means inside secondary signal, you may have two or more primary signals. When I say you have two or more primary signals, that means it has more than one frequency. Why? Assume your secondary signal has two primary signals. Suppose your secondary signal is a one that built by two primary signals. In that case, one primary signal has one frequency, means two primary signals having two frequencies. Therefore, secondary signal should have two or more frequencies. Don't worry, probably you may not see the relationship of signal and frequency at this stage, but maybe during coming slides we may try to understand it. Therefore, at this stage, for understanding from syllabus point of view, we need to divide our signals into two categories. One primary signal, the other one is secondary signal. Right? Primary signal and secondary signals. Primary means a signal that has only one frequency. Secondary means a signal that has more than one frequency. That's the simple definition that can be quoted for primary and secondary. If someone asks what are the examples for primary signals, you can say cos signal and sine signal. Cos and sine signal are the only signals that you can quote as primary signals, because all these secondary signals, what we call as maybe sawtooth signal, a signal that has a kind of a short sawtooth shape, or any kind of arbitrary random signal, maybe something like say this any random signal that has a random shape, can be built by adding certain number of primary signals, right? Certain number of primary signals. Therefore, examples for primary signals are very clear. For primary signals, it may be either a cos signal or a sine signal. Secondary signal means a sawtooth signal, triangular signal, or any signal that has a different shape, than sine and cos. And at the same time, to understand these signals, what you call primary and secondary, we may need to draw those signals. For example, here I just sketch some signals here, but you need to draw or sketch those signals in a proper manner so that at least you can see the signal. You can see the signal. By seeing those signals, you may be understand, plus you may be able to differentiate those signals from one to other. To do that, we can put signal into a graph, or signals can be represented in graphical form. For example, very first important signal graphical representation is called as time domain representation. Time domain representation. Sometimes you may not heard this particular word, time domain, but maybe you have already drawn signal against time. Time domain means you are drawing your signals against time. Or in other words, whenever you draw signals in a graph, your x-axis will be time. X-axis will be time. Therefore, when you draw signals against time, means signals variation against time over time is the shape of the signal. From that way, you may be able to understand how these signals vary, right? That's one of the way you can understand, or at least you can see signals. Once you see the signal, of course, you can discuss their attributes, properties, likewise. And at the same time, Signals can be discussed, explained, or draw against frequency as well. Means your frequency axis will be the x-axis. Or in other words, your frequency axis will be the independent variable axis. Such a way, you may be able to understand the behavior of signals. For example, you may find a picture like this, or something like you may see something like this, right? Maybe you have not seen, you have never drawn this signals against frequency. That is what is called the frequency domain. Means to understand signals, you can use frequency domain as well. When I propose you to use this frequency domain, that means you are drawing your signals against the frequency axis. By doing that, you may be able to understand, or you may be able to tell something more about the frequencies, something more about your signals against its frequency content. Sometimes you may have already heard, for example, while you are doing your A-level physics, there was a particular same equipment in your physics subject called cathode ray oscilloscope or oscilloscope, CRO, cathode ray oscilloscope. And this cathode ray oscilloscope is the device, is a particular device that can draw signals against time. For example, through cathode ray oscilloscope, you can see there you have a screen, like a TV screen, a very small screen. You can draw signals against time and see those things. Therefore, this cathode ray oscilloscope is a device that can show signals on time domain. And at the same time, there is other device called, maybe you have not heard it. There is a device called spectrum analyzer, and that device can show signals against frequencies. So that particular device can show frequency content of a particular signal. That is normally what we call as the spectrum. Therefore, this particular device is called as a spectrum analyzer. Spectrum analyzer is a device that tell you something about frequency domain. Of course, this particular device seems a very expensive device. Probably universities, some of the academic institutions may have this device. Of course, almost all mobile operators are having this device. Not in all places, but in very limited places. Maybe, for example, Dialog may have one spectrum analyzer only, because its price may be something like 30, 40, 3, 4, 6 million like price, depending on the size or the model of particular device. Or probably nowadays you may find say computer applications as well, where you have to plug a particular specific card, so that your computer also may become a spectrum analyzer as well as CRO. That kind of facilities also will be there. In that case, maybe prices probably might be a little lower as well. Therefore, to understand these signal, whatever called primary, secondary, analog, digital, maybe low frequency, high frequency, all these type of signals, we can use this time domain concept, and as well as we can use this frequency domain concept. By using either time domain concept or the frequency domain concept, we may be able to see signals. By seeing them, we can discuss their maximum amplitude, period, frequency, or whatever the attribute, but we need to focus. And at the same time, in certain cases, we talk about signal behavior or signal variation over the distance as well, especially in communication or in mobile communication. Why? Because you may have already heard that we normally say my antenna is transmitting a particular signal from my base station, and signal goes to a person or goes to a receiver that is maybe 20 kilometers away from my transmitter. That means my signal goes from my base station, transmitter station, to the receiver, and the distance between the transmitter and the receiver is 20 kilometers. Means signals can travel as well. Therefore, the signal behavior or the values of signals can be drawn against the distance as well. That is also one of the other way of looking at signal, which is very important for our subject as well. That's mainly about signals. I guess now you understood at least some concept called signal categories, especially from mobile communication subject point of view. Signal can be categorized into two main categories. One is called primary signal, or sometimes we call it as a fundamental signal. If someone asks what is this fundamental signal, you can say yes, fundamental signal is a signal that has only one frequency. That is the answer. If that person asks one more question to indicate what the example that you can quote for fundamental signals, you have two answers. You can say either a cos signal or a sine signal, because cos signal and sine signal are the only fundamental signal available. Of course, you can say sec, cosec as well, but primarily what we say is cosine. And if someone asks what is this secondary signal, now you know the answer. Secondary signal means a signal that has more than two frequencies. Or if not, you can say secondary signals are the signals that built by adding two or more fundamental frequencies. That answer also correct in a way. And from that, what you need to finally get is secondary signals has more than one frequency component. Don't worry. We need to study, we need to learn, we need to understand what this frequency means, because during our entire session, the word called frequency will be a particular word that may dominate. Everywhere you may heard frequencies, signals and things like as well. Therefore, we need to understand what this frequency means in detail, maybe by doing some calculations as well. Don't worry. At this stage, I just indicate certain say definitions, categorizations and things like, but will when you go slide by slide, when you go module by module, you may understand all these things. And on the other hand, if someone asks how you see signals, if someone asks how you see all these different signals, but different signal categories or different signals, what you say is we can see signals specially in three ways. One, from time domain. Second, from frequency domain. From the propagation point of view. Especially these two are very important, time domain and frequency domain. Frequency can be seen or drawn against time, means x-axis is time. Such drawings are called as time domain drawings. And same way, frequency can be drawn against the frequency domain as well. For example, here your x-axis will be frequency. And there are certain occasions, especially in mobile communication, that we talk about signal propagation. Means we need to understand the behavior of the signal over the distance as well. Therefore, we may draw graphs to show signals over distance, right? Over distance, how your signal vary, right? This kind of graphs also will be drawn. And at the same time, when I say signal, what is this signal means really? Signal means three things. One, a voltage. For example, for a particular voltage, you may say a signal. Sometimes we call as a voltage signal. Or if not, you may say a current. Current can be considered as a signal because in your electronic telecommunication circuits, once you power the circuit, there is a current. And when you draw the current in a graph, you can see how the current behavior may be against time, against frequency. And this current also called as a signal. Therefore, from circuit point of view, current and voltage are the two main type of signals what you are finding. Other than these two, there is one other signal as well, which you can say power signal or power behavior of the power. You know the relationship between voltage, current and power. Power equal voltage multiplied by current. Therefore, when you multiply voltage signal with the current signal, you may automatically get the power signal. And even you can say power is the third category of signal which you may encounter, which you may see, hear, discuss, touch during this particular syllabus as well. Right. I hope you got a little bit of understanding on signals, signal categories, and the concept called time domain, the concept called frequency domain. Don't worry. I know you didn't understood it more than maybe 40%, but don't worry. We need to get it little by little while we are going through respective modules, because today is not the last day. Today is the first day, and we need to go through the entire syllabus during next couple of months, so that you may be able to understand what really time domain means, what really frequency domain means, because those two concepts are very important concepts, especially in communication. Of course, mobile communication is part of the communication. Right.